Okay, let's go for section three. Force applied in the change transmission. Okay, let's go over with the motions of the force in chain transmission. We have a sprocket there, rotate in the uh, counterclockwise direction, and then we have a F sub T. Okay, it's going to be tension in the upper belt there, and then we have the first contact between the rollers and the sprocket there. Okay, so therefore this is the point of contact, first contact on the first point there. So therefore we have three forces induced right there. Okay, so therefore we have Ft, okay, the line of action is there, and F sub in the line of action is there, and F sub L is line of action is there. So therefore, okay, we have 3 point intersect at the same point. So therefore, in the theory, we're gonna have a polygon of the force in the closed loop, okay, in equilibrium. So therefore, we have Ft equal to F sub L1, F sub N1 plus each other is equal to F sub T then. So therefore, this is in equilibrium. Okay. So let's see for this is the first pin there, and the second pin is already contact there. We have again three forces. FL1 is right there. Okay, and FN2 is there, and FL2 is there. Intersect at one point there, and then we have a polygon there in a closed loop again. We have the FL1, FN2, and FL2 respectively. And for the pin number three, there's again we have three forces, and then the pin number four, we have three forces in equilibrium again. For the last point here, okay, we're gonna see there F sub T, and then F sub L is gonna be less, and F sub 2 is gonna be less, and then F sub 3 is gonna be less, and FL4 is gonna be really less anyway. So this way, this one up to the last point of contact here. We have no just a little amount of force left over, so that's why the chains here is gonna have no tensions anymore. So that's why it's gonna be reliable only on its own weight. So that's why it's gonna do some sacking. Okay, so this one, so therefore, you apply on this the chain drive transmission. You're gonna have a sag induced during the motion. This is gonna be the most major concern of the force drive in the chain transmission system. Another one we gonna talk about the angle of alpha or the angle of contact or angle of articulation. In figure 2.9 here, the chain approach to the sprocket with an angle of alpha there. Okay, so therefore, the what we got there, the pitch angle can also be defined as the angle which the link swing as its enter contact, or also can be called the angle of articulation. Okay, so the term alpha here is going to be very important in terms of wear and tears. Okay, but alpha has some relationship with the number of teeth, okay, of the sprocket itself. So therefore, in order to talk about the alpha, we rather talk about the zeta. So therefore, under the experiment, under the study, it found that the very low chain speed, the C minimum is recommended to be 12. It's mean if you're gonna go design for the low chain speed anyway, you got to make a selection of the pinion not to be less than 12, things like that. Okay, and then slow chain, high speed chain, really high speed chain is going to go 25, and even you go for driving mechanism to increase the speed, you're going to go for 23, things like that. Okay, in your sense, it's very difficult to verify what does it mean by very slow and slow, things like that. I tell you what, very slow and slow, things like that, is going to typically, that's the normal machine in industry, things like that. Okay, For the high and very high is going to be classified as in the automotive engineers, things like engineering, things like that. Okay, or vehicle, things like design, whatever. Okay, for the increased speed. Okay, so that's why we no doubt about it. We're gonna go for 23. Another important thing, anyway, to make wear and tear to be more uniform, the number of sprocket teeth is gonna be odd number. Okay, and the chain roller should be even. Okay, to make it well contact in the front and in the rear respectively. Okay, and then the chain tension force or tension force of F sub T. F sub T again, like in the chapter one, that when we talk about the belt design again, F sub T is equal to W sub P over V. Okay, and then this one, the W sub P can be either between from 2 pi T time N. Okay, whereas the V term is gonna be equal to pi T time N respectively. Okay. And then another term is F sub I. Initial tension force can be able to determine from this equation. Okay, F sub I given from F sub T is Z sub B, number of sprocket, and C sub B equal to B times beta times C times over 360. B is the angle of contact, and phi is the pressure angle. Okay, and then typically F sub I is gonna be very small. Okay, for instance, like if we got beta 120 and then alpha is 15 and C is 19, F sub I is going to be about 0.76%. Okay, F sub T or 0.0076, very small anyway. And then another term is going to be centrifugal force, F sub C there. And then the real sub, F sub C is not the big concern with us anyway. It's going to be centrifugal force. But the things that what we really need is F sub CT based on the vector polygon there. And then F sub CT is going to be equal to W over G times V square. Okay, for the analysis anyway. Okay.